Today, we're going to learn about solving systems of linear equations using a method called elimination. The idea behind the elimination method is to combine two equations so that one variable is eliminated, making it easier to solve for the remaining variable. This method works especially well when the coefficients of one variable are opposites or can easily be made opposites. Here's the general process. We start by writing the two equations in standard form. This is the standard form of an equation where both x and y are on the same side of the equation. This makes it easier to combine the equations. Next, we look for a way to eliminate one variable by adding or subtracting the equations. If the coefficients of one variable are not already opposites, we can multiply one or both equations by a constant to make them opposites. For example, in our system, we can see that the coefficients of y are already opposites, plus 2y and negative 2y. Thus, we can add the equations directly. Now, we add the two equations to eliminate the y terms. We're left with a simple equation in terms of x only. In this case, adding the two equations gives us the following equation. Once we have an equation with only one variable, we solve it. Here, we divide both sides by 5. Now that we know x equals 3, we substitute this value back into one of the original equations to solve for y. Let's substitute it into the first equation. That's the elimination method. By eliminating one variable, we simplify the system to find the solution more easily. In this case, our solution is x equals 3 and y equals 3 over 2. Next, we'll work through some examples together to practice this method. Solve the following system of equations using elimination. Since the coefficients of y are opposites, we can add the two equations directly to eliminate y. Let's add them now. Now, we can solve for x by dividing both sides of the equation by 6. Next, we substitute x equals 3 back into one of the original equations to solve for y. Let's use the first equation. We then simplify the equation to find the value of y. Now, we solve for y by subtracting 6 from both sides. Then, divide by 3. So, the solution to the system of equations is x equals 3 and y equals 2. A farmer is planting two types of crops, corn and wheat. Each acre of corn yields $120 in profit, and each acre of wheat yields $150 in profit. If the farmer plants a total of 40 acres and earns $5,400 in profit, how many acres of each crop did the farmer plant? We start by defining our variables. Let x represent the number of acres of corn planted, and y represent the number of acres of wheat planted. Now, we set up two equations based on the information given in the problem. In this step, we will eliminate one of the variables, either x or y. To do this, we need to make the coefficients of one variable the same in both equations. Let's eliminate x, as its coefficients in the two equations are different, 120 in the second equation and 1 in the first. To make the coefficient of x in the first equation match with that in the second equation, we multiply the entire first equation by 120. This ensures that the coefficients of x in both equations will be the same. Let's multiply the first equation by 120. Notice that by multiplying the first equation by 120, we've now made the coefficient of x the same in both equations. This will allow us to subtract the equations to eliminate x. Next, we subtract the first equation from the second equation to eliminate x. By subtracting, we get rid of x entirely from the system and are left with only one variable, y. Notice how the 120x terms cancel out, leaving us with just 30y equals 600, which is much simpler to solve. Now, solve for y. Now that we know y equals 20, substitute this value back into the first equation to find x. By solving, we find that the number of acres of corn planted is 20. The farmer planted 20 acres of corn and 20 acres of wheat, so option A is the correct answer. Great job! Let's quickly recap what we've learned today about solving systems of equations using the elimination method. The goal of elimination is to eliminate one variable by either adding or subtracting the equations, depending on whether the coefficients are the same or opposites. Steps of the elimination method. Line up the equations in standard form. Make the coefficients of one variable either the same or opposites by multiplying, if necessary. If the coefficients are the same, subtract the equations to eliminate that variable. If the coefficients are opposites, add the equations to eliminate that variable. Solve for the remaining variable. Substitute the solution back into one of the original equations to find the other variable. Remember, the elimination method can be used flexibly. If the coefficients are the same, subtract the equations. If the coefficients are opposites, add them. Keep practicing, and soon you'll feel confident solving any system of equations using the elimination method.